Welcome back. I hope you're enjoying these videos as much as I'm enjoying making them. Now for the next one. We've got 3.6, Prime Decomposition. So please go ahead and write that title down in your notebooks. Okay, now there's a few things you need to know when we're learning about this topic. So I just wanted to revise and make sure that you're aware of a few things. So we need to remember that prime numbers are whole numbers that have exactly two factors. They don't have 1, they don't have 3, they don't have 72. They have exactly only two factors. 1 and the number itself. So only 1 and the number itself can actually multiply into it. Alright, now composite number though is a bit different. It's a number greater than 1 and has more than two factors. So it can have any number of factors, but it just needs to be more than 2. Now, number 1 has only got one factor, so it's actually neither a prime nor a composite number. It doesn't have exactly two factors, it only has one, so therefore it can't be prime. And it's not composite because it doesn't have more than two factors. The same with 0, it doesn't fall into either of those categories, so it is neither prime nor composite. Now, when we're talking about decomposition, if you think about it, it means like decomposing. So we're breaking it down. So we're breaking down any number into its prime factors. Now every number can be broken down so far that it actually ends up in prime numbers. So that's what prime decomposition is. And we need to write it as a product of its prime numbers. So when you multiply all the prime numbers together, you'll actually get that number. So as you can see, my little writing symbol here. So can you please write that down? Right, so prime factors. So factors that are prime numbers are called prime factors. So we need to break the number down until we can't go down any further, and the numbers, all the numbers we find are prime. And you may have come across this before in using a factor tree to find the prime factors. Now every factor tree eventually ends up in prime factors. So can you please write this down? And then I'm going to go ahead and show you how to break down the number 50. Alright, here we go. So 50. Now you can multiply 2 by 25 to get 50. So let's do that. So we're putting 2 and 25, so we multiply them together. Alright, now, are any of these numbers prime numbers? Well, you know that 2 is a prime number, so we don't have to do anything else with that because that's already broken down into prime number. Now what about 25? Can we break that down any further? Well, yes we can, of course. So 5 5s are 25. And then we can see that we've got 5s because that's a prime number. So now we have broken down 50 into its prime factors. Now the way that we write this for our answer is that we write therefore. So you know this symbol, it actually means therefore 50 equals 2 times, and when we're writing this, we've got more than one number that's the same, then we can use powers. So we learnt about powers before, so we use the powers to represent it. Instead of having to write the number twice, we just write 5 to the power of 2. So 50 equals 2 times 5 to the power of 2. So please write that example down. Alright, now one other thing to remember when you're working out the prime factors, don't worry about which two numbers you use first of all to multiply to make the number. Now I'm going to show you here that it doesn't matter which numbers you use to multiply, as long as they make 60 in this case, then it'll still break down into the same prime factors. Alright, so there's heaps of different ways you can multiply to get certain numbers. So I'm just going to choose 2 of them. So 60 can be, so 2 times 30. Okay, so 2 is a prime number. We still need to break down 30. 6 5s are 30. And we know that 5 is a prime number. Still breaking down 6. So 2 times 3 is 6. And there we have the prime factors of 60. Alright, now let's try 5 12s are 60. See if we get the same result. Okay, and now 5 is a prime number. 2 6s are 12. And again, it doesn't matter which way you do it here. And then 2 times 3 is 6. Okay, so let's have a look. We've got 2 2s, a 3, and a 5. Exactly the same. Alright, so then when we're writing this, and when we write it, we need to write the numbers in ascending order. So we're writing therefore 60 equals, will be 2 squared times 3 times 5. And there you have it. So it doesn't matter which pair of factors that you start with, it just matters the end ones, and they'll be the same no matter which 2 you start with. Okay, I want you to try this yourself. Pause the video and write this down, and then see if you come up with the same prime factors as me. So you're going to have to express 80 in prime factor form. So pause the video now and do it yourself, then I'll show you the answer in a minute. Okay, so doing fact truth 80 now, it doesn't matter what you use. So I'm going to use 2 times 40. 2 is a prime number. Then 40, well, 4 10s are 40. Okay, neither of those are prime numbers still. 2 times 2 is 4. And we've hit some prime numbers here. We've got 2 times 5 is 10. And here we go. They're all prime numbers. Now, did you write the answer properly using the therefore symbol? Therefore, 80 as a product of prime factors is, where we got 4 2s, so 2 to the power of 4 times 5. Remember, we're writing them in order, so we don't write the 5 first, we're writing the 2 first. So we're writing them in ascending order. So 80 equals 2 to the power of 4 times 5. I hope you got that answer. Well done if you did. Okay, we're going to do some activities now at school. So good luck.